Saxon Algebra 1, Lesson 17. I'm here to talk to you today about our old friend, the distributive property. We talked about this a lot last year. We're going to use distributive property a ton. It will become like second nature. But before I get into the particulars of that, I want to just review a couple terms that we use quite often. And I remember when I was an algebra student, my teacher would throw these words around and I sort of knew what he or she meant. I had male and female teachers. I sort of just had like an intuitive hunch of what they meant, but I really didn't understand. So I'm going to take a minute and try to explain them. You probably still will be sort of like, I'm not exactly sure. And that's okay. Factor. Anything that we multiply together to form a product is called a factor. Okay, so it's something that we multiply. The answer is called the product. We can have lots of factors, right? We can multiply a clump of things. They can be letters or numbers. So we give them the name coefficient. That means factor. It's really the same thing. A coefficient is a factor. It's one part of a multiplication problem. However, we can break coefficients down into what we call numeric coefficients. And I'll show you an example in just a second. And another name for that is a constant. Or we can call them, so I'm going to use the same word. Or we can call them, I'm trying to think of the word that usually appears in front of it, and I'm drawing a blank. If it's a letter, we just call it a plain coefficient. When we just have a letter, right, like an X or a Y, and that's called a variable. Because as you know, we can plug in different values to that variable and solve it. So in the example 4x, y, right? This is an indicated product, which means we know we're supposed to multiply. There are three different parts. These are all called factors. So 4 and x and y are each factors in this expression. They're also coefficients. We can say that each one of them, 4, is a coefficient of the others, x, y. We can also say that x is a coefficient of 4 and y, and we can say that y is a coefficient of 4 and x. So we can call each one of them a coefficient of the others. 4 is a numeric coefficient, and these are just plain coefficients. That's easy to tell apart, right? This is numbers. And this is letters. Make sense? Okay, now let's take on the concept of terms. That's another one. I toss that around all the time, but I never really take the time to explain it. The reason why is because terms can be so confusing, but it's such a simple idea. Let me just write this down. I explained it recently, I think, to you guys. Terms are clumps of information that either has value or could have value, right? 8 has value. X does not, but if we said X equals 17, then we could give it value. So it could have value. But the important part with terms are the plus and minus signs. The plus and minus signs show us the breaks in between the terms. Now, that gets confusing because, for example, this has a plus, but that's a plus within the term, right? The breaks between the terms, you can kind of see with your eye if you just look at it, right? I can see that's a clump, so I know that's a term. It's connected, this plus sign is connected to the top by this division bar, so that all lives by itself. So X is a term, 4xym is a term, 6p plus y over 2 is a term, and 8 is a term. Some mathematicians consider the minus signs in between them to be just links between. I usually prefer to see the sign as a part of the term that comes after, right? So every term has a sign as well. That's part of its package. And then the front one, if there isn't a minus sign, we know that's a plus as well. So every term is a unit that either is a number or could be turned into a number, right? We could turn any of these into a number if someone told us what to plug in or if we got to choose. Every term has a sign, and every term has this kind of strange disconnect from the other terms in the same expression or equation. So we can see the dividing lines, and like I said, I always think of it as train cars, right? That they're like the links between the different cars. Some cars are simple, some cars are fancy, but they all connect with a plus or a minus. All right, so that's what terms are. Terms can include multiple factors, as we see. They can include both numeric and regular coefficients. They can include division, and there can be addition or subtraction within the division, okay? Ooh, that's a lot. That's just vocabulary. We use those words all the time. I try to use them correctly. And you'll just get more used to them as we go. Now we're ready to talk about the actual distributive property. And I'm going to show you one example before I give you the general rule. 17.1. Use the distributive property to find the value of 4 times the quantity Okay, so this has no variable coefficients, right? These are all numeric coefficients. So what that allows us to do is we don't really have to use the distributive property because we would simplify within the parentheses first, wouldn't we? Order of operations, right? We would do that first. So we would rewrite this as 4 times, let's see, 6 minus 2 is 4, plus 5 is 9, minus 7 is 2. And we would get an answer here of 8. Okay? So when we have all numeric coefficients, we don't need to use the distributive property. We can just work within the parentheses. The distributive property becomes important when we throw the letters into the mix. Okay? In the example of this problem, we can't do anything within the parentheses first like we could do here. There's no way to simplify that. So instead, because we want to get rid of the parentheses, obviously we're trying to simplify this, what we can do is multiply. mnx plus mny, right? I'm multiplying these two, then I'm multiplying these two, then I'm going to multiply the last ones. 2mnp. I always put my terms into ABC order, alphabetical order, because then if we're combining with other terms, it just makes it easier to sort out what we've got. It keeps things neater and better. Now, to prove to you that this works, I'm going to go back to this problem, and now that we've seen how distributive property works, I'm going to solve this again using distributive property, pretending that I can't just use order of operations to fix that, and let's see if it works. So this is 17.1 using distributive property. I'm just going to write it again so we can see all the numbers. 6 minus 2 plus 5 minus 7. Okay? So I'm drawing these to help me remember all the different steps I need. This one will have 4 steps. 4 times 6 is 24. Minus 4 times 2 is 8. Plus 4 times 5 is 20. Minus 4 times 7 is 28. Okay? Now what I'm going to do, because this is a little more complicated addition, I'm going to put the 2 positives together and then the 2 negatives together. This is 44 minus those 2 together is 36, and look what that equals, 8. Yay! This was the right answer here. I didn't do that. Now, what this proves to you is A, the distributive property works. You'll get the same answer as if you do it using order of operations. The second conclusion we can draw from this is that if you do have numbers and you can use order of operations to complete this work first, it's way easier. Multiplying everything all out creates a little bit of complication, and so if you don't have to, don't do it. But I did this to prove to you that you will get the same answer, and the distributive property is our friend. Let's write the distributive property as a rule so that we can remember it. And this is something you would want to write in your formulas and notes. Distributive property. And we're going to use letters to show it. If you have, remember it's a term on the outside and then at least 2 on the inside. You can do 3 or 4 or 5. It doesn't change anything. What you do is you multiply the outside times the first one and then add the outside times the second one. All right? And I use these little marks to help me remember. I got a problem on a test wrong once when I was in Algebra 1 because I multiplied the first one, but then I just copied the second one. I didn't remember to multiply the second one. I learned my lesson. Okay, let's do a couple more. Oh, I wanted to puffy cloud of knowledge this. We'll use this a ton. Use the distributive property to expand. Expand is a word that means multiply. It means take away the parentheses. Now this one looks slightly different. What looks weird about this one is that the outside number, like the A that we have here, is on the right instead of the left. Usually we see the number up here. And this time we have the parenthesis bit first, and then the outside number is over here. That's okay. No big deal. All we have to do is just draw our lines going back the other way, and that will walk us through it. So now I'm going to multiply MP times X, and I'm going to write it in alphabetical order, MPX. Since this is positive out here, I know that all my signs are going to stay the same in here. If this is negative, it's a different ball game, but for now, I know my signs aren't going to change, so I'm just going to put that minus sign there. Now I've got a numeric coefficient as well as these variable coefficients, so I'm going to write 3MPY. ABC order, plus, now I'm going to put this last multiplication together, and it's MPXZ. All right, so that is our quote-unquote expanded. Let me just read it. MPX minus 3YMP. If the letters are in a different order, that means that John doesn't care as much about ABC order as I do. But it's fine because in multiplication, which this is a big multiplication, right? Each of these are factors as well as coefficients. Order doesn't matter, so we're good. MPXZ. Okay, good. This is the right answer. Beautiful. And our last problem for today, 17.4, use the distributive property to expand. Oh, well, John's going to do exactly what I just talked about. He's going to put a negative number out here. All right, we'll cope with that. Again, I like to do this, so I'll always remember to do both. And we just make sure that the minus sign stays in our heads as we multiply. Minus 3 times 2x, well, let's see, that would become minus 6x, right? And then minus 3 times minus 4 would become plus, 2 minuses make a plus, 12. All right? So what we see is that if there's a minus sign on the outside of the distribution, we just have to be careful to include that with each of the two multiplications and follow our same rules for getting the signs right. There's nothing different about it. We just have to remember it. Oops, I just made my eyeballs go sideways. Wow. That is a scary looking smiley face. But guess what? We're done. And I just want to show you one problem in the practice that's a little bit confusing. It's super wordy. Okay, evaluate by adding and then multiplying. So he wants you to add first. Evaluate by multiplying and then adding. Okay, so he wants you to do 4 times 5 is 20, minus 4 times 3 is 12, right? So just like we did the one problem 2 different ways, he wants you to do it 2 different ways. Use the letters A, B, and C in parentheses to write the distributive property, just like that. That's what G means by that one. I'm helping you with your homework. And then this one, when we multiply first, we say we are using the distributive property. Use the distributive property to evaluate. So he wants you to multiply 4 times 6, 4 times 2, 4 times 5, 4 times 7, and then summarize it. He doesn't want you to use order of operations first. He wants you to use distributive property first. So that's doing it the long way and making all the numbers bigger. And then down here, these are the more straightforward problems. Expand by using distributive property. There you go. There you go, right? And remember that just because there are 3 pieces, it doesn't matter. You just have a third multiplication. All right, and then he gets into some term kinds of things. What is a coefficient? What is a numeric coefficient? What is a literal coefficient? If you want to get the exact words, you can look on pages 74 and 75 and just copy them. Or what you can do, what's fine with me, is give an example of what those would look like. All right? Any problem that has lots of words for the answer, you can bet is going to annoy me somewhat, and I don't get real excited about it. All right? If you can do the calculations, then that means you do understand, even if your brain doesn't know all the words. Okay, guess what? I'm done. Yay! Goodbye.